So now we're looking at arctangent of what's a good thing to arctangent?
Root 3.
Root 3, okay, good. Let's pick that at random. Pick a number at random, square root of 3. Okay, arctangent of root 3. How do you do that? So I'll let you do it with the pointer.
Okay. So you'd find where root 3 is. Oh, you'd have to do the slope.
So what's a line with
So,
slope root 3? I mean, just guess. You know,
okay.
like, how's it look?
About there.
Right, okay, steeper than
Than
45
1.
degrees,
45
right?
degrees,
If
yeah.
it was 1 over root 3, it would be that one.
Yeah.
And if it was 1, it would be
right
that
there.
one. And because it's root 3, it's like that one,
Exactly.
right? Okay, and that kind of, that sort of tells us what to do then.
Yeah.
So now I'm going to draw that in there. A good way to figure out something with slope root 3 would be to go ahead and draw your points where they're supposed to be and then connect them. And just, do you remember what thing actually has length root 3? Do you remember this? About how if I draw this tangent right here, so I'll draw it. Hold on. This length, the blue length, actually is root 3.
Oh, okay.
Okay? And that's why tangent gets its name. So let me do a little more artwork here. So if this distance right here is this distance is 1, right? Because it's the radius of the unit circle.
Right.
And if the slope of the line is tangent of theta, right? Then if my equation is y equals mx, and I plug in x equals 1, which is what I'm doing when I'm looking for this point,
Right.
right? Then what I get is that y equals m,
Okay.
which is tangent of theta. Another way to think about it is I can start with the unit circle, triangle, which we all know has size cosine theta,
Right. And sine theta.
sine theta, and 1. Right? Okay, what do I do to trade a triangle? I want to trade this small triangle for the big triangle, which means I trade cosine theta for 1. It means that what I did was I took cosine theta and I multiplied it times 1 over cosine theta,
Okay.
which means this side becomes sine theta over cosine theta. And this side, which used to be 1, is now 1 over cosine theta. Right? Okay, so that tells us, like, this side of the triangle is secant. Okay? So in our picture here, what we have are sine theta, cosine theta, then we have tangent theta, and secant theta.
Okay.
Okay? All in the picture.
Right.
All right. So that's always useful. People say tangent equals sine over cosine, and in the law firm of trigonometry, sine, tangent, and secant are like partners. They like founded the law firm of trigonometry. Okay, so cosine is like just graduated. You know, the idea that tangent is somehow dependent on cosine is totally wrong.
Okay.
Okay, so tangent on the unit circle is this length. Okay, all right, so that's good. Okay, we got a little sidetracked with the whole, like, don't relegate tangent to
Yeah.
being subservient to cosine, and the fact that sine, tangent, and secant are the founders of the law firm of trigonometry. But the whole point of this was to figure out arctangent of root 3. And we agreed that it was whatever angle makes this line, okay?
Right.
And of course we draw in the right triangle and we see it's 30, 60, 90, right? So that means we either care about this angle, which is what?
60.
Pi
over 3.
Adults call that pi over 3,
Yes.
right? And then we care about this other weirdo angle. Well, not really. If I just want to say what arctangent is, it's pi over 3.
Right.
Right, because arctangent looks at this part of the circle and calls it a day. Right, just like for for arcsine and arctangent, we're looking at the green part of the circle. Okay, so for arcsine and arctangent, we're looking for the green part of the circle, and then for arc cosine, we're looking at the orange part of the circle.
Right.
And I guess you were taking stuff pre-calculus, like from a book,
Yeah.
where they do like arc secant and arc all
Oh,
that kind
we
of
haven't learned
stuff.
about that.
Yeah, I can't imagine a world in which I care about arc secant. Anyway, so arctangent of root 3 is pi over 3, but let's say we wanted to solve the equation tangent of theta equals root 3, right? Now what?
Then it would be pi over 3.
Theta equals certainly pi over 3 plus any multiple of pi, right? What is theta also?
Negative. Negative pi. No, not negative pi over 3.
There's actually a little trick about tangent, and that is tangent repeats every pi,
Right.
right? So we actually can make life easier by saying that instead of having 2k pi, we can just say pi over 3 plus k pi.
Okay.
Okay, that's different from sine and cosine. You can't do that.
Because that's 2 pi.
But well, just like, because if I was solving, let's say, if I was solving sine of theta equals 1/2, right? Then I'd go through and I'd do this kind of thing, and I'd point to that point and point to that point. Now my angles are, pi over 6 and 5 pi over 6. It's not that sine repeats
Oh, okay.
every pi. There are two answers to sine of theta equals 1/2. The two answers, the two fundamental answers, are pi over 6 and 5 pi over 6. But individually, I have to add 2 pi to each of these
Okay.
to get all my answers. However, for tangent, I can say just add multiples of pi,
Okay.
because of the way, essentially, if I draw a line, it cuts the circle in half, right? And if I have tangent here, then I repeat the value of tangent here, and so on. Okay.